tornadoes, hurricanes, earthquakes, scary events. What this is about are things that are not so friendly in life. They're not great for our health, our happiness, or even our safety. Nature's little villains, if you will. This is what prompted us to make something, a design, that would actually resist the tornadoes, hurricanes, and earthquakes that we see happen every day throughout the entire globe. After years of calculations, we actually came up with a wood-structured unit designed specifically to resist these kind of nature's little villains.
But how do you test this? Since all tornadoes, hurricanes, earthquakes act differently, we needed to pick the worst case scenario.
And in this case, the worst case scenario is an EF5 tornado. Now, an EF5 tornado, what makes this so scary, they have the highest wind speeds recorded, and that is speeds that go up to as high as 235 miles per hour. Now, these things, hurricanes are similar to tornadoes, but they're kind of like lesser tornadoes with wind speeds. However, hurricanes move something that's much heavier, and that's mainly water. A hurricane is equivalent to taking your house and placing it in a car wash for like 4 days. That's the damage that a hurricane does. However, for our purposes, for testing to really show things coming through, the tornado is king.
And there's also earthquakes. Now, earthquakes is a different situation. And with earthquakes, the failure comes to shaking. Like a good example is like a game that my dad taught us, where you do wrestling and you go back and forth until finally the building fails. Thanks, Bob, for making me look good by faking that fall.
My pleasure.
Now, we went and did calculations with the Federal Emergency Management Agency,
Also known as
FEMA! And what happens is that FEMA has a requirement for earthquake loads that if you take the highest wind event, that will override any earthquake loading.
This is true. Again, with an EF5, the wind speeds reach up to 235 miles per hour. This causes a lot of devastation. For example, we had actually seen footage of a brick and stone house that was lifted completely off its foundation and then obliterated in the air, all by an EF5 tornado.
Not to mention the Wizard of Oz.
Well, that's very true, the Wizard of Oz, but that was a nicer one because at least they stayed in one piece.
It never blew apart.
That is true.
Those plastic models tend to do that.
Yeah, you know. Well, that's Hollywood. Yeah. These EF5 tornadoes, they can be as big as a mile wide, and they can cut grooves into the earth for as long as they want to go. Very, very dangerous things, okay? But what we're going to find out is we're going to take a look at the differences of the different types of testing that Chuck had mentioned before. What we find is that the standard test, the accepted test, is one that's typically done with a form of a blower. And by blower, we mean anywhere from huge fans, multiple huge fans, jet engines, car jets, all these kind of things that blow wind there. The problem is with that is that these tests, the winds, are localized. And by localized, it means it comes out in a limited stream. For example, it would be like me spraying Chuck with a hose versus him getting hit by a tsunami. The hose moves faster, but it's not moving as much.
So what we decided to do was to build a better mousetrap. What we did was we added up all the forces, and if you look at this equation here, this surface here is 8 square feet. That's 2 feet by 4 feet. So what we decided to do was take the equivalent force. Now, the famous formula, force of wind equals 0.00256 V squared. V being the 235 miles an hour. Now what that does is that nets an equivalent force of 141 pounds per square foot. So if you take that times the 8 square feet, that means that we could put a force on this box of 1,128 pounds. That's a lot of force.
That brings up a good point. And that is, well, if we're going to exert force on the box, which test is more effective? Now, the items that we're going to use to compare the tests between a wind force test versus a different type of test, which is called a tension test, is going to lead us to the following items. First off, we have our leaf blower. With the leaf blower, 220 miles per hour. What does that mean? Well, that puts us right where we want to be. That's right in the range of an EF5 tornado. Okay? In addition to that, we're also going to need a cable. Oops. Or in this particular case, we're just going to use a heavy-duty rock climbing rope. Okay? We also are going to use something called a dynamometer. The dynamometer is this extremely heavy-duty gauge that's designed, in this case, to measure up to 20,000 pounds. That's 10 tons, folks. So the dynamometer is going to establish how much force that I can apply to the testing. Okay? Lastly, we're going to need a house. Well, in this case, we're going to call this our residential testing unit, or
RTU.
That's right. And our RTU happens to be, well, it's a cardboard box. Okay? Ta-da! Now, what we're going to first do to establish force is I'm going to take the dynamometer and I'm going to do my best to put as much muscle into it to find out how much force I can apply.
Alright, let's put this thing
Chuck, if you'd be so kind. We're going to hook this up to a hook against the house because chances are that won't move. And I'm going to do my best to see how much force we can put on here. Ready?
Alright, let's see this.
1, 2, 3.
Give it a pull! Give it a pull! Wow, you can do it! Come on! Alright, we show 200 pounds. So you
200 pounds. So I am able to put 200 pounds of pressure or force onto something. But first, let's go back to our blower test. Let's take a look and see how that works. Chuck, would you be so kind as to do the honors?
That would be my pleasure, sir.
Okay, don't remember, safety first.
Absolutely.
What we're going to do here is we're going to show that the blower is actually blowing. Let's take a look and see what we've got. Chuck's going to crank this baby out. That's a leaf blower. So, thank you, sir. We're going to go ahead and see what it does to the house. Because according to the tests, if this can move 220 miles an hour, that's like an EF5 tornado. Let's see how our house holds up.
I would say this house just withstood, according to this test, an EF5 tornado. So this cardboard box can handle an EF5 tornado if you use this test as criterion.
So what you're saying is the blower test might not be accurate because according to what we just showed, it shows here that this would be tornado proof for an EF5 tornado. Now this is a cardboard box. I find that hard to believe. So let's show our form of test. And in this particular version, thank you, what we're going to do is we're now going to take our cable, we're going to wrap this cable around the box, and I'm only going to exert, as it was proven, a mere 200 pounds of force on the box. And let's find out what that does for us. Ready? Here we go. And that also continues to prove our case. So, what we're showing is that the tension test is substantially stronger than the wind test. Now that we've discovered that tension tests are stronger than wind tests, that's going to lead us to our next steps.